system by graphing. Notice both equations are in standard form. We have to get them in slope-intercept form in order to graph. So I'm going to rewrite the first equation first. So if x minus 2y equals 16, I have to get y by itself, so I subtract x on both sides of the equal sign. On the left side I have negative 2y, and on the right side I have negative x plus 16. I have to isolate the y, so I divide both sides of the equal sign by negative 2. On the left side I have y left over. Negative 2 divided by negative 2 is just 1. And then on the right side I have negative 1 divided by negative 2, which is positive 1/2. Bring down the x. And then positive 16 divided by negative 2 is negative 8. And I do the same thing with the second equation. So I have to isolate the y. I subtract 6x on both sides of the equal sign. So 6x minus 6x cancels out, so I have negative y equals negative 6x minus 3. I have to get y by itself, so I divide by the negative 1 on both sides of the equal sign. So on the left side I have y left over, and on the right side I have negative 6 divided by negative 1 is positive 6x, and then negative 3 divided by negative 1 is positive 3. Alright, so now in order to graph, I have to figure out my slope and my y-intercept. The slope of the first equation is 1/2, and the y-intercept is negative 8. The slope of the second equation is 6, and the y-intercept is 3. So when graphing, I always start with the y-intercept. So the y-intercept of the first equation is negative 8, so I put a dot at negative 8. And my slope helps me figure out the next point. So my slope is 1/2, so I go up 1 to the right 2. I'm going to extend my line and go down 1 to the left 2. I'm going to connect my points. And you do the same thing with the second line. My y-intercept is at 3. And slope is 6. So I go up 6 to the right 1. And then same thing, but now I go down 6 to the left 1 to extend the line. And then I connect the dots. The solution to the system is the intersection point, which is at -2, -9.